So in the last video, we gave Scratch the instructions, the recipe if you like, the algorithm for how to draw a square. Now we could go back here and say, actually that square is too big, Scratch. Let's make it half the size. I deleted a block there. Let's drop that back in here. Somehow I did something and I lost the block. So let's say move 100 steps, move 100 steps. I need to come and edit each of these to say 100. So I'm clicking in there. Oh, I moved it to the end. That's where it went. And 100. And then let's run that with the green flag. I'm going to pop Scratch over here. Oh, what happened here? I must have reordered something. Oh, yeah. So we took out, did I take out too many turns? I don't know what happened. So we had this pattern, didn't we? Move, wait, turn. Let's pop that back in again. Move, wait, turn. Move, wait, turn. Move, wait, turn. Up. Move. I think that's right. Let's try it here. That was debugging I just had to do there. Okay, so we've got a square now half the size because each side is 100 steps. But the corners stayed the same because we still want them to be right angles. Now, we gave Scratch every instruction. We micromanaged Scratch in a way. Now here's where the power of coding really becomes apparent, because we can get rid of all of those blocks if we just put them inside a loop. Now, we know that squares have 4 sides. And so we should here be able to draw a square with 3 blocks inside 1 repeat. But we do it 4 times. Let's see what happens. And we come back and we've drawn a square. Now this is much easier to update. Let's say I want somewhere in between our 2 squares. So 200 was too many, 100 is too small. Now I only have to update in one place. And I get a square. Okay, so this is the power of coding, is that we can loop things. Means we only have to update one place. Means there's less room for bugs and errors to occur because I can see very clearly, yep, move, wait, turn. I don't have to check it 4 times or 10 times or 200 times because we might be doing a shape with 200 sides. And all I need to do then would be to change the numbers here to 200. Now, before we get to 200-sided shapes, let's go back one side and try and get a triangle out of this. I'm going to take you through my thought process here because I'm not in the room with you. Now, if we just put 3 sides, we don't get a triangle. We get 3/4 of a square. So what do we think we need to change here? We change this, we get shorter sides, but that won't change anything apart from having a smaller 3/4 square. So it must be degrees. Now one way to do this is just to try random numbers. So 90 is not right. What about 100? Let's try that. Oh, let's not lose Scratch. Okay, so I'm going to bring Scratch over here and run that again. Okay, well it's more triangular than it was. If we were to continue all the way up here, we'd end up with some kind of triangle. The sides wouldn't all be the same length. So we're going in the right direction maybe. So let's try 110 here. Now I'm going to add one more block in here, and that's point in direction, which will mean that Scratch always points to the right whenever we run this code, and that's just going to help with us not shooting off the edge. Okay, we're getting more triangular-ish, aren't we? Let's try another one here. Let's try 120. See what we get. Perfect. Look, we've got ourselves a triangle. So we only had to repeat 3 times, and we ended up with a triangle. Now, some of you might be thinking that you know the internal angles of a triangle should add up to 180 degrees. And that's true. But what we're doing here, if you understand that, then see if this makes sense to you. When Scratch comes along here, Scratch is facing this direction. Now, it's not the internal distance we're measuring here. It's how much Scratch turns from here all the way around to here. So it's more than 90 degrees turn, and it's 120 degrees that Scratch turns until Scratch is facing this way, and then Scratch can walk along here. Then Scratch is facing along this path, so Scratch has to turn another 120 degrees to be able to draw this line, because it's external angles we're talking about. If you imagine a straight line across here, it's the difference between there to there. All right? So some of you might have thought, that should be 60. We should be turning 60. But actually, it's the rest of the 180 degrees that's a straight line. Okay? So it's 120. If that makes sense to you, great. If not, then don't worry at all. So we've got a triangle. So the next thing for you guys to do is to see if we can draw a square. Let's recap that. It's never a bad idea to recap what we've just learnt. So what should that be here? 4 sides now will give us the same triangle. We've just drawn one of them twice. I don't know if you can see that slightly thicker there. So remember, it's the degrees we need to change, and we had 90 in here for a square. So let's try that now. Where's my green flag? There we go. So we've got our square back. And at this point, we could have a look at drawing a 5-sided polygon. These are regular polygons. All of the angles on the corners and all of the sides are the same length. So these polygons, does anyone know what a 5-sided one's called? What's a 5-sided polygon called? That's right, it's a pentagon. So here we go. We've put 5 sides in. Do we get a pentagon? No, we still get a square. So it's the degrees in here we need to change. And I think we need 72 degrees in here. And I'm going to make my sides slightly shorter, because as we get more sides, the area, the size of our shape increases. So I'm going to pop Scratch down here somewhere and see if I can draw a pentagon. There we go. Pentagons. Now, if we were doing this in class, I'd get you to do the next steps on your own through trial and error. But because I'm here on the other side of the computer, I'm going to give you a formula. I'm going to show you how, in the next video, how to work out any sided polygon that we can draw in Scratch. So this could be a 7-sided polygon, a heptagon. Could be a 10-sided polygon, a decagon. It could be a 47-sided polygon, which I've got no idea what it's called. But there's a simple formula I'm going to teach you in the next slide, the next video rather, that will show you how to do that.